Okay, then let's have a look at this series then. We've got a third, take a ninth, plus a 27th, minus 1 over 81. Now I've got alternating signs, and we mentioned that in the intro, question 0, that we can introduce alternating signs. It's either going to be of this form, in terms of a counting digit, or we may need to change the value of r to r minus 1, depending on whether you start with a plus or a minus. So this is what you've got to look out for, okay? When we tweak it for the plus and the minuses. But let's just worry about the fraction first of all, the substantive part of the problem, and then we'll worry about tweaking it for the plus and alternating signs in the series. Okay, can you see what happens? The subsequent term is a third times the preceding term, isn't it? A third times this is that, times by a third is that, times by a third. Right, we'll worry about the alternating minus signs in just a tick. So, okay. Good. So we can write the first term then as a third. And then the ninth we can write as a third squared. Why not do that, yeah? And then the 27th we can write as 1/3 cubed. And the 1 over 81 we can write as 1 over 3 to the power of 4. There we go. So now, what can we do? Well, the minus. With this rule in mind here that we mentioned in the intro, this minus can be written as minus 1 to the power 1. Yeah? This plus can be introduced as an alternating sign as minus 1 squared, can't it? And this minus can be written as minus 1 cubed. And that way, we've incorporated the alternating sign in a way that allows for a counting digit. See here? 1, powers of minus 1 increment from 1, 2, and 3. While the powers of the fraction in this example go from 2, 3, and 4. So there's a patterns here, isn't there? The only thing, everything looks okay. I'm fairly happy with all these terms. This one needs tweaking to make it look like these subsequent terms. So I need to put a minus 1 to a power in here, and I can always put minus 1 to the 0. The third itself, by default, is power 1, so we better put that in now. So what have we got then? Well, we've got 1/3 to the power r minus 1 to a power we don't know. I'm not going to put the minus 1 power in yet. I'm going to leave that, but I know the third will be r, and that will be when r is 2. This is when r is 1. Agreed? And the next one, this will be 1/3 to the r when r is 3. And then we just carry on. It's an infinite sequence of carrying it. And the fourth term, I could put it in, but I'm just going to leave it there like so, because it's identical. Okay, so the only thing I haven't done is when r was 1, this was third r. A third squared and a third cubed. We were happy with that. Now this power, do you notice it? That was 0 when this is 1. So if r is 1 and this is 0, to write this in terms of r, I'd need to take 1 away, wouldn't I? So I could write that as r minus 1. And the same goes here. This is power 1. 2 take 1, so r minus 1 can go there. R minus 1 can go here. So can you see we've got a pattern emerging? Yeah? So now we've verified it, we can write the series in sigma notation. So it's a third to the power r minus 1 to the power 1 less. Let me just write that out with a little bit more room. So it's a third to the power r minus 1 to the r minus 1. There we go. And we started from r equals 1, and we went, it's an infinite sequence. There we go. That's question 6 done. And you could use rules of indices to tidy this up. But you've got the sum from 1 to infinity of minus 1 to the r minus 1 times by a third to the power r. And it could be tidied up if you wish. Good.